Now that we have the law of cosines, we can solve for triangles that have three sides involved and one angle. I'd like to skip example 1 and jump right to example 2. We'll come back to example 1 on your companion sheet momentarily. So I'd like you to write down a law of cosines version that involves r, s, and t, where t is the angle that's involved. Play the recording when you've got it. Okay, so hopefully you wrote down this. Angle t is the one involved. So side t is off by itself. S squared and r squared are interchangeable because we're squaring and adding. Minus 2sr. If you wrote rs, that's cool. The important thing is that you get angle t and side t in the right place. The rest is pretty easy. You're going to substitute in all the information you know. So t squared is unknown, s and r are known, as is angle t. Notice how everything on the right side now are numbers. So we can just put this straight into our calculator. Comes out to be 397. That's not the answer though. Obviously we couldn't have a side 397 with other sides 11 and 12. So of course there's one more step. We have to square root 397 in order to solve for t. Well, that's easy enough. Put that in your calculator and you got 19.92. At this point we should ask ourselves, is that a reasonable side length for this triangle? Well, angle t was the 120 degrees. That's the obtuse angle. We would expect the side across from it, side t, to be the largest side. So that does make sense, 19.92. But of course also, it can't be bigger than these two sides combined, otherwise we just don't make a triangle. The third side can't be larger than the other two sides combined. So 11 plus 12 is 23. This is less than that. It seems to fit. Let's go back to question number 1. Okay, I skipped this one initially because it's a little strange, and it's given information that instead of giving us the measure of angle B, it's telling us what the cosine of B is equal to. But that's no problem. We're still going to set up our law of cosines the same. So write down on your paper your version of law of cosines that involves angle B, as well as sides A, B, and C. Play the recording when you've got it. So hopefully you wrote this down. Angle B, cosine of B, and then side B, of course, by itself. Those have to match up. Okay? Now it's just sub in all the stuff you know. Okay? So 4 squared plus 6 squared minus 2 times 4 times 6, but instead of cosine of B, there's no cosine involved because the value of cosine of B is 1/16. Okay, so it's not cosine of 1/16. Cosine of B is 1/16, so it's just the fraction here. Again, these are all numbers. Pop that in your calculator, comes out to be a 49. So when you square root, B is equal to 7. Does that make sense? Well, I suppose it could work with side lengths 4 and 6. Seems reasonable. In example 3. In fact, in example 3, 4, and 5, the directions are the same. You're going to find the measure of the angle to the nearest degree. I'll walk through number 3 with you, then I'd like you to work out 4 and 5 on your own. I think you'll understand what to do at that point. Okay? So because we're solving for angle C, I want you to set up a version of law of cosines that involves angle C. Play the recording when you've written it down. Okay, so hopefully you wrote that. Angle C is here. Little side C is on its own. Sub in everything you know. Okay, so hopefully you subbed in all this information, but notice how it's not all numbers on the right side. The unknown, the variable, is over here, so we're going to have to use some algebra. We can't simply put it all into our calculator to get the answer yet. Really want you to concentrate on this explanation because students invariably make a mistake here. Okay? Let's do the math. We have to square the 3 and square the 4, then we have to multiply. Negative 2 times 3 times 4. Looks like this, right? 9 plus 16 minus 24 cosine C. Okay, when you multiply 2 times 3, it's 6. 6 times 4 is 24. Now, 9 plus 6 obviously is 25. At this point, this is the place where the students potentially make a mistake. They see 24 minus 25 and they want to write 1. Let me give you a similar situation to try to clear that up for you. Okay, over on the right here I've written a very similar equation. 4 equals 25 minus 24x. I don't think any of you would think, oh, these are like terms, I can just add them together and say it's 1x, right? That would be absurd. You got rid of that notion back in 9th grade, maybe earlier. So don't do that here. Remember, cosine of c is just a variable. I can't combine it with 25. They're unlike terms. So what can I do? Well, I can simply subtract the 25 from both sides and get a negative 21 on the left side. So negative 21 equals negative 24 cosine c. Divide by this coefficient. Divide both sides by negative 24. And then I have cosine of c is equal to 21/24. And I need to use the inverse cosine to solve for c. So I'll go to my calculator. I'll do inverse cosine of 21/24. And I'll get 29 degrees. I need to look and see if that makes any sense. C is the smallest side, so I would expect it to be across from the smallest angle. And 29 is a pretty small angle, so that seems reasonable. At this point, I think I've given you enough background to be able to work out questions 4 and 5. I want you to pause this recording, work out angle C in question 4 and question 5 on your own, get your answers, and then play the recording just to check it. I'm just going to go very quickly through and show the answers for those. Okay, so hopefully you got an answer for number 4. You set up your law of cosines, which is the same exact law of cosines before. Sub in all your stuff. Do the arithmetic here, but again, these aren't like terms. These are the 9 and 16, put those together. You can't do 25 minus 24 and say it's 1. You cannot do it, because these aren't like terms. So instead, we subtract the 25 from both sides, and here you get a 0 on this side. Well, that makes some folks uncomfortable, but that's not a problem. We can still divide by negative 24 on both sides, and we get 0. So again, looking for the angle, do the inverse cosine of 0, and we get 90 degrees. So, 90 degrees. That's interesting. Must be a right triangle. Well, let's look back at the given information. It was a 3, 4, 5. Of course, that's a right triangle, right? It's a Pythagorean triple. And the 5 would have to be the hypotenuse because it's the biggest side, so therefore it would be across from the 90-degree angle. It all makes sense. The last one you're looking at, I'm just going to go through and show the notes. Okay, you make all the substitutions, do the same work as before, do the inverse cosine, and now we get the angle of 117 degrees. That makes sense. It's the largest angle. It's across from the largest side. Okay, leave you with this final example, number 6. This is the one I'd like you to work out. Put into your quiz on Edmodo when you found the largest angle to the nearest degree. Thanks for watching.